Hello. In this video we want to introduce you to the concept of multi-threading. So it turns out that these days pretty much every device that you buy has a chip that has multiple cores on it. Now most of the programs that we've been writing so far have been single-threaded. And one way to think about that and what that means is that as the program runs, there is one place in the program that is executing at a given time. You might picture this in your code listing as a little arrow, and that arrow goes from one line to the next to the next. If it goes inside of a loop, it'll jump back to the top and it'll jump around, but there's always one arrow that's moving around. When you multi-thread a program, you have the possibility to have multiple arrows that are in different parts of the program, and if the hardware that you're running on supports it, they will happen at the exact same time. Now, why is this important to us? To understand this, it helps to have some knowledge of what has happened with processors. So here's a nice little chart. You can see the credits here for it. That takes you through some of the history of processors going back into the 1970s. But what we really care about is what's happened since around 2000. And in particular, we care about the green points and the black points here. So the green points are showing us the frequency that the processors run at, clock speed. And basically through most of the history of computer processors, this curve was going up and up and up until around 2005 when it really leveled off. Now while this plot ends at 2010, it turns out that all the way up to 2016 when I'm making this video, this has stayed fairly level. The laws of physics don't really like us pushing processors that much faster than 2, 3, 4 gigahertz. However, the performance of processors has continued to improve, and the way that that has happened, so during this regime, prior to 2005, performance got better because the clock speeds increased. Starting in 2005, you'll notice that the number of cores on a chip started to increase. So here's an example of an AMD Opteron, which had 4 cores on it. What that means is there are actually 4 little processors on there. And those 4 processors can do 4 things at one time. It's like having the ability to have 4 little arrows pointing into your code that are all running at the same time. As long as you arrange things properly, that means that you can get things done 4 times faster. And so the overall performance of the chips has continued to increase, even though the performance of a single core generally has not increased all that much since about 2005. There have been some improvements, but the bigger improvements come from adding more and more cores. As I said, I'm recording this in early 2016. At this point, you pretty much can't buy a processor that only has a single core. Even your cell phones now will have 4 or 8 cores on them. And at the high end, you have processors that have very large numbers of cores. I'm making this recording on a processor, a machine that has 2 processors. Technically, each one supports 12 cores, so I have a total of 24 cores, but each one allows 2 threads to run simultaneously, so I have 48 threads on this machine. But there are also processors, like Intel has a line called the Xeon Phi, also known as like the Knights processors. There was Knights Corner. The current one at this time is Knights Landing. Knights Landing has 72 cores. Each one supports 4 threads for a total of 288 threads in that are supported by that device. And so if you really want to fully utilize it, you have to not do 1 or 2 things at a time. You have to do 288 things simultaneously in order to really get the most out of your hardware. Graphics processors are also basically computer processors at this point in time, and they also work by being very highly parallel. They don't get as much done in a single thread as a normal processor, but they have lots of cores in them. A high-end Kepler K80 has almost 5,000 threads that will run simultaneously. So in order to get things done, you have to write your program so that things happen at the same time. That's multi-threading. It's actually one of the great strengths of Scala, and this is what we really want to look at. Because as you can see, if you're only running a single thread, you basically stopped gaining much performance in 2005. The computers aren't benefiting much for a single thread. If you really want to have better performance, you have to start using multiple cores, and that requires using multiple threads. Now, note that there are some challenges to using multiple threads. We'll talk about the difficulties that you have. The way that we're going to run through this is we're actually kind of going to go, what I would say is look at the right ways to do multi-threading. We're going to talk about parallel collections, we're going to talk about futures, we're going to talk about actors in Scala. After we're done with that, we will look at lower level libraries, which is kind of the foundation of how multi-threading works. I'm doing things in this order because my experience is that most people kind of latch on to the first thing that they see, and I want people to understand the right way to do it as opposed to getting stuck on the wrong way and then not paying as much attention when we get to the right way. So, I should also note that even if you aren't going for high performance, so maybe you're writing some other application that isn't supposed to be crunching a lot of numbers or processing lots of data, there is still a reason for you to want to do multi-threading. And that is because programs that are multi-threaded are typically more responsive. The one thing that you have written to this point that was actually multi-threaded, even though you didn't necessarily know it, was the GUI code. Okay? When you write graphical user interfaces, they inherently use multiple threads, and that helps them to be more responsive and to work with the user. So we'll come back in the following videos and we'll go through and look at the different ways in which Scala supports multi-threading.